Hey everyone, welcome back to Algebra 2. Today we're doing lesson 6.7. This is going to be a two-part lesson, so there'll be a part 2 coming in the next lesson. They do get a little more complicated. Today we're going to start with the more basic side of this topic. So solving radical equations. So we're going to be looking at equations that have square roots in them. So we still want to solve those. We want to find the solution or solutions to that equation. Going back to Algebra 1 or even before then, if you started in like a pre-algebra class, there is a common theme for solving equations. You want to isolate the variable. You want to do inverse operations, so like the inverse of plus is minus and times is divide. And then whatever you do, you need to do the same to both sides of the equal sign. So here's a real basic example, not Algebra 2 level at all, very basic. Starting with 2x minus 1 equals 15. Our goal, of course, is to isolate the variable. Under the minus 1, we do plus 1 because those are opposites or inverses. They cancel each other out. But you also do plus 1 to the other side. That's where the 16 comes from. This is 2 times x. So to, again, isolate the variable, the opposite of times is divide. You need to divide by 2, and you do that to the other side as well. 16 divided by 2 works out to be 8. That is the solution. You probably don't do this, but you know it's the solution because when you plug it back into the equation and work it out, the answer you get matches the answer to the equation. So that's why it is a solution. So we're going to be doing that, but the equations will have square roots in them. To cancel out a square root, you must square both sides. Square means to raise to the second power. Keep in mind that a half power is the same as a square root. So even though I'm presenting this as solving equations with square roots in them, this could also be viewed as solving equations with half powers in them. When those examples come up, I'll point it out. Finally, just like we know the solution means you can plug it in and get the answer, in some of these problems we get what's called an extraneous solution. You do all the steps correctly and it works out to give you an answer, but then when you plug that answer back into the equation, it actually does not solve the equation. So that's a thing that can happen that we are going to look out for. All these answers say remember to check for extraneous solutions. Basically what it comes down to though is trying to square root a negative number. Remember, you can't square root negatives unless you get into imaginary numbers, and these equations were only going to be in the realm of real numbers. So like number 2, if we worked this all out and we got x equals negative 100, obviously that can't work because when you plug it in, you'd be doing the square root of a negative 100, which you can't do. So that would be an extraneous solution. That doesn't mean all negative answers are wrong, because sometimes when you plug a negative number in, something will happen and it will turn positive. Maybe it gets added to a bigger number or something. So you can't just assume negative numbers are going to be wrong. But there are times where you plug in a number and it works out to be a negative square root, which is imaginary, and you can't have those in this context. All right, let's get to examples. I don't think I really need to lecture on a bunch of points and principles and stuff. I'll get through the evens like usual. You see this is a fairly lengthy assignment. 20 problems, but that, if I do the evens, you only have 10 problems for homework. And at least at the beginning, they go kind of fast. So here goes. So we want to solve for x, isolate the variable. I'm going to start by subtracting 9 on both sides. That's a pretty normal type of thing you would do to solve an equation. You get square root of x over 10 equals 18 minus 9 is 9. Now to isolate x, we need to get rid of or eliminate that square root symbol. So like I said before, the opposite of a square root is a square. A square and a square root cancel each other, and that just gives you x over 10. Of course, if you square one side, you have to square the other side. You have to do the same thing to both sides of the equal sign, and 9 squared is 81. Now are we done? No, we still have to isolate the variable, but that's pretty simple. This is divide by 10. The opposite of divide by 10 is multiply by 10. Times and divide by 10 cancels out, and you get 81 times 10, which is 810 as the answer. If you try to check yourself, 9 plus the square root of 810 divided by 10. Oops, wow. Boy, I'm real smart. 810 divided by 10. Look, if you're lazy or if you're just not feeling it, maybe you're not a lazy person, that's kind of harsh, but maybe you just don't feel like doing it, you can just type in 9 plus square root of 810 divided by 10, and you get 18. So we're good. That is the answer. And if you check it on the calculator like that, you probably don't need to scroll down and check your answer, but I'm going to anyway, just to be sure. Excuse me. So there we go. Let's do the next one. Again, our goal is to isolate the variable. We're going to start with this -2 right here. Now you might see that and be tempted to go, oh, -2 plus 2, those are opposites. Well, adding is the opposite of subtraction, but that's not subtraction, that's just a negative number. The operation is times. That's -2 times the square root of 78 minus n. So we need to divide both sides by -2 for our first step. Now, -18 divided by -2 is +9. Equals square root of 78 minus n. We are at the point where we want to cancel out the square root, so that means you have to square it, square the other side. And sort of coincidentally, we get 9 squared again, which is 81. Okay, whatever. Square root cancels out 78 minus n. I'm going to subtract 78 on both sides. I get 81 minus 78 is 3 equals -n. Now, n is not isolated. That negative sign is there. We need to cancel out the negative. So just think of this as a -1 times n and divide by -1. To cancel that out, you get n equals -3. That should be our answer. So you want to do -2 times the square root of 78 minus -3. Plug your answer in and see if it's right. -2 square root 78 minus -3. And that does work out to equal -18. Which is what we're looking for, so that is the right answer. Scroll down to number 4 and look, and we are good. Let's check out this one. Okay, so here's one where we have a fractional power. There's 2 ways you could work this out. It's going to be the same thing either way. What you could do is rewrite the original problem like this. And now it's going to go through all the same steps as every other problem. So that's cool. You can do that. Or you can leave it as a fractional power and just work it out from here, which I'm going to go ahead and do just to show you what it would be like. So I'm going to start by subtracting 6 to cancel that out. 9 equals, wow, this software sure likes the number 9 to the 1/2. To cancel out a half power, you want to square both sides. A half times 2 just cancels out. You get 81 equals 80 minus k. Subtract 80 on both sides. 1 equals -k. Just like we had that -n up there, we have a -k here, so divide by -1 to cancel that out. K equals -1 should be our answer. Let's check it. 6 plus 80 minus -1 to the 1/2 power. So clear all this out of Desmos. 6 plus parenthesis 80 minus -1 close parenthesis raised to the 1/2 power equals 15, and that is right, so we know that is the right answer. So the first page of this worksheet, none of them answers are extraneous. They're all just fairly simple. In fact, I don't think we get extraneous for a little while, but I'll keep on doing them just like you should do them. Number 8 is kind of unique because there is a square root on both sides of the equal sign. To solve this, you square both sides to cancel out both square roots, and you get 14 minus x equals x plus 4. From here, because we do have x on both sides of the equal sign, we need to get like terms together. So I'm going to go ahead and add x. 14 equals x plus x is 2x plus 4. Now we can subtract 4. You get 10 equals 2x, and divide by 2, x equals 5. So that should be our answer. If we go to check it, I need to go back to the original problem. And because there's an x on both sides of the equal sign, I'm supposed to plug a 5 into each one. So 1, I've got square root of 14 minus 5, and I get 3. And then just on a new line on the calculator, I'm going to do a square root of 5 plus 4. And you see there on the screen, I get equals 3 on both of them. So They both equal 3. That means that is correct. It is not extraneous. Number 8, boy, if I scroll down, is 5 right there. Now, do make sure you show your work on these assignments. I'm kicking back a lot of assignments to people who aren't showing work. You don't have to do every single step. Like if you can do 10 divided by 2 in your head and you know the answer is 5, you don't necessarily have to write everything out like I do, but you got to do, some of the work on paper. All right, number 10, both sides are raised to the half power. So that means I want to raise both sides to the second power. Halves and 2's cancel each other out. I get 20 minus r equals r minus 6. From here, I'm going to get the variable terms together. So I'll plus r, and I'll cancel that out. 20 equals 2r minus 6. Add 6 to each side. 26 equals 2r. Divide by 2, r equals 13. Thinking that's right, but I'm going to check it on the calculator anyway. So I have parenthesis 20 minus 13 parenthesis raised to the 1/2 power. That's kind of messy. Let's do the other side. 13 minus 6 raised to the 1/2 power. And it doesn't matter that it's a decimal or that it's an irrational number. They equal each other, which means it is correct. So, yay, go us. Number 12, similar to number 10 in a way, they're both to the 1/2 power, so we square both sides to cancel those out. 2n minus 63 equals n over 4. Now, I'm going to talk about that n over 4. There's a process called clearing the fractions that makes equations easier to solve. When you have one or more fractions in an equation, you look at the denominator, or if there's more than one, common denominator, and simply multiply the whole equation by that denominator. And we use a distributive property. So when I multiply to here, n over 4 times 4 cancels out the 4 and you get n. But then you also have to distribute to here, which I can't do 63 times 4 in my head. 63 times 4 is 252. And then distribute to here. 4 times 2n, that's 8n. I can do that in my head. So now we need to get our variable terms together. I'm going to go ahead and subtract 8n. Negative 252 equals 1 minus 8 is negative 7n. Divide both sides by negative 7. Negative 252 divided by negative 7 is 36. N equals 36. Let me check my answer. So I'm going to go back up here to the original problem. Do parenthesis 2 times 36 minus 60. Oops, back the truck up. 2 times 36 minus 63 raised to the 1/2 power. That works out to equal 3. Let's do the other side. 36 divided by 4, close parenthesis, raised to the 1/2 power is also 3. Both of those equal 3. 36 is the right answer. Check number 12. And again, no extraneous solutions. Holy cow. Well, let's keep going. All right, so what did we have? We had equations with a square root in them, and then just numbers. We had 2 square roots, one on each side, and you square them, it cancels them out. Now we've got 1 square root on one side, but then a variable on the other side. This is going to be a little bit trickier to do. All right, so to work this out, I am going to have to cancel out that square root. To do that, I obviously am going to use a square, and you have to do the same to the other side. This cancels out. I get negative 20 plus 9n equals n squared. Now we've got an equation with n and n squared in it. If you recall, this is called a quadratic. And we spent a lot of time learning how to solve quadratics. One thing is for sure, when you have a quadratic, you want one side to equal 0. So I'm going to go ahead and add 20 and minus 9n, add 20. And that's going to make this side just a 0. I'm going to have n squared minus 9n plus 20. To solve this, we had a choice of options. You can do factoring, you can do something called completing the square, or you can do the quadratic formula. It's your choice what you want to use. Factoring is usually the easiest route. Factoring does not always work, but when it does work, it's easier. So I'm going to try factoring. So this is that process where you got to think of two numbers that multiply to 20 and add to -9. You remember doing that? And multiply to 20, add to -9. How about 4 and 5? -4 and -5. Yeah, 4 times 5 is 20. -4 and -5 is -9. So now you set each factor equal to 0 and solve them. So add 4, n equals 4. Add 5, n equals 5. So it looks like we have two answers. We just have to check them to make sure we are correct. So first, this might look a little tricky. I'm going to plug in a 4, and that should equal 4. It says you got to plug in a 4 into both spots. So here, square root of -20 plus 9 times 4. And that does equal 4, just like it's supposed to. So that's good. Now let's do square root of -20 plus 9 times 5, and that equals 5. So if you plug in a 5 on this side, it equals a 5 on that side. So that's a good answer. So both of those are good answers. They are not extraneous. 4 and 5, both good answers. Are we ever going to find an extraneous solution? Holy cow. All right, let's try number 16. Again, just like the last problem, you need to square both sides in order to cancel out the square root. You get 56 minus b equals b squared. Just like the last problem, we need one side to equal 0, so I'm going to minus 56 plus b. That's going to make both of these cancel out and give me a 0, but that means I have to plus b and minus 56 on the other side. And since this is a quadratic, I need to factor it, hopefully factor it. I need two numbers that multiply to -56 and add up to +1. Remember that b technically has a 1 there. And I think that's pretty easy, right? +8 and -7. They multiply to -56, they add up to +1. So b plus 8 equals 0, b minus 7 equals 0. Subtract 8 on both sides, you get -8. Add 7 on both sides, you get 7. So again, it looks like two answers. Let's plug them into the original and check. When I plug in -8, let's see what happens. So I have square root of 56 minus -8. That gives me, you see the calculator screen says +8. It's supposed to give me -8. But it doesn't. That means that -8 is not the right answer. Cannot possibly be the right answer. You plug in a -8, you're supposed to get -8 for an answer, and you don't. So that is extraneous. Let's check 7 as well. Plug in a 7 here, and do we get a 7 there? So square root of 56 minus 7. We do indeed get 7. So 7 is the only good answer. -8 is what we call extraneous, like extra. It is not good. 7 is the only answer. So now hopefully you see what it looks like when you get an extraneous solution. We have a few more of these just for practice. So number 18, go ahead and square both sides. Cancels out. 63 plus 2v equals v squared. Minus 63 minus 2v on both sides. Oops. That way this cancels out. 0 equals v squared minus 2v minus 63. Go ahead and factor that. It's going to be v and v. And what times what is 63? Oh, 7 times 9. 7 times 9, right? If we had a +7 and a -9, that's going to add up to -2. Set these equal to 0. Minus 7, v equals -7, plus 9, v equals 9. So we get two answers. I'm not going to circle them yet because we need to check them. When you plug in a -7, do you get out a -7? That is the question. Square root 63 plus 2 times -7. Oh, that's 2 minus 7. I want 2 times -7. Ooh, we get a +7 for an answer, not a -7. So that is extraneous. Let's try square root of 63 plus 2 times 9. Okay, so when we plug in a 9 here, we do get a 9 out for an answer, so that is a good answer. Number 18 should just be 9. There it is. And let's do number 20, and we will be done. Okay, this one looks a little different, but still we've got a variable on one side. Oops, I'm supposed to highlight that. Variable on one side, square root on the other. So let's square both sides. Cancels that out. K squared equals 8k. Again, we want one side to be 0. I'm going to go ahead and subtract 8k from both sides. K squared minus 8k. Those are not like terms. You cannot combine them. You just write down k squared minus 8k. The other side is a 0. When we factor this, because it's not a trinomial, I'm not going to do this kind of factoring. We need to do common factoring. Both terms have a k in common, so you bring out the k, and you get k minus 8. Now set each factor equal to 0 and solve them. Well, this one's already solved, 0. This one I need to add 8 to both sides, k equals 8. So I get two answers. Is either one extraneous? Well, let me plug them in and see. A 0 here and a 0 there. I don't know if you need a calculator for that. 8 times 0 is 0, and the square root of 0 is 0. You plug in a 0, you get out a 0. That's a right answer. Let's plug in 8. Probably don't need a calculator for this, right? 8 times 8 is 60, not 88. Times 8 is 64, and the square root of 64 is 8. So if you plug in an 8, you get out an 8. So both of those are right answers. The answer to number 20, where is it? 0 and 8. Okay. Probably you've noticed as I've scrolled through, one of your problems is no solution. So it is possible that when you work this all out, maybe you get two solutions. When you plug them in, they both work out to be extraneous. So if they're both extraneous, you just write no solution. Make sure you do show your work on this assignment as much as possible. If you have questions or problems, contact me. Otherwise, I'm not going to ramble on and on about this. Just good luck, and I will talk to you again soon.